Yeah, hello guys, good day. Welcome to our new course of Python in machine learning, and today is our first lecture. We are starting with our core functionalities, but today's lecture is just an introduction lecture. So, best of luck with all your learnings, and put in the comment section whatever your questions are. I'll make sure to upload the lectures regularly. So today we are going to discuss uh, what is machine learning and why do we need it, and what are the circumstances in which we prefer the machine to work for us, and what are the circumstances in which we prefer the human to work for us. So we have particular questions here like why do we need machine learning. So all of you can think about it. First of all, if we have a numerical value which we do want to multiply, like there's a value 2 multiply 3 and we just want the multiplication of this, and if we go with the human calculations, this will take up to 2 to 3 minutes for us, a human which is better at mathematics, but for adult student it can take up to 10 minutes as well. But what if this operation is done by a machine? Machine will not take even a complete second to complete this operation. And then similar is the thing. Suppose we have a 500 pages of directory, which is in a hard form and a soft form as well. Suppose we let a human to find a chapter or a word in that directory of 500 pages, so it can take up to from 10 minutes to 10 hours as well. Because if human need to find a word, it can take up to hours, and if we need to find a chapter, it can take up to minutes. But what if we give a PDF to machine and ask machine to find a word? Machine can find that word in 30 seconds, and even can find the multiple occurrences of that word as well. This is how machine is fast and how it is helping us in today's era. Then again, who can perform better is the question. This is not always the machine and also not always the human. There are circum conditions where machine is preferred, and as well there are circum conditions where the human is preferred. So who is better on what? This is the question here. If we have large calculations, just like multiplication, addition, and then doing multiple mathematical calculations, doing physics calculations, and doing chemical equation solving, the machine is much more better than a human. The machine can perform thousand times better, even more than that, as compared to a human. Suppose we have searching of records like we discussed before, like searching in a 500 pages directory. Again, the machine is preferred here on humans. But wait, not always the machine is better. Suppose we have a condition of thinking of driving a car. I know there are multiple companies nowadays, like there is Google, there is Tesla, which are working in the field of driverless cars, but those projects are not 100% perfect. Uh, there can be thousands of conditions in which their driverless cars can fail. Although they should be appreciated because they have covered most of the cases, and those cars are successfully running on roads as well, but those cars cannot match with all conditions, and they always need human assistance in case of failure. Then again, think about war. We have robots nowadays which can go into war, which can play in the wars, but they cannot think like human, so they cannot differentiate between enemies and their own soldiers. So this is the condition again where machine can fail. I'm not saying machine is failing. Machine can pass circum conditions, but machine can fail as well. So the reason is the human can think slower but better than machine. This is the main phrase which is discussed here. Like the human machines can think slower than a computer machine, but a human can think better than a computer. A computer cannot actually compete human while making decisions. Computer can just make decision faster than human if they are trained well. Then how machine learning works? Suppose we need to teach a machine to learn something. We need to provide data to machine, like input data, and then we need to provide output data as well. So what machine do? Machine makes a mapping from input to outputs, and based on that mapping, the machine stores the future mappings as well. Machines have like human mind can store like hundreds or thousands of transactions at a time, but machines can store trillions. So there making a machine learn is that's why easy, because machine doesn't lack of memory. Nowadays we have smaller chips storing trillions of data, so whenever we are low, a lack of memory, we can just upgrade our machine. That's not a problem anymore. But that trillions of transaction memory can be used here to store data for the machines. So what we can do, we can make test data just like we are telling our calculator like 5 plus 5 is a 10, and we showed calculator a transaction perspective. The calculation takes it that learning into account, and later on any digits are added or addition is performed, the calculator performs the same transaction for 5 plus 5. So the calculator learns to do addition. Similar is with the subtraction. And if we come to the Tesla's car, suppose the driverless car, that car knows whenever there's an obstacle within some distance of meter, the car either needs to stop or either needs to try to change his lane. This is the test data for the car. The car performs the same data and go up to with the successful path, or the car can even save from accidents. But this is not the best case always. The data used by machine learning is called the training data, and the data which we pass to machine learning to test if it is working fine or not, that is called the test data. There are circum examples of machine learning, like in future we'll be exploring on it in more detail. But for now we will look into some circum examples. Like there's a spam filter example. You have seen in Google, Gmail, or in Yahoo, or in any your mail, like you in a Hotmail, we have seen a spam folder, and certain of our emails are moved to spam automatically. How Gmail detect that it is a spam? This is based on the training data actually. The Gmail is trained with training data of spam filters. Like each and every type of spam email is passed to Gmail to train Gmail. So what Gmail does on each email, the Gmail runs an algorithm mapping the data of the email to the spam data the Gmail has in his training data. So if any of the data matches with the trained data, the Gmail thinks like this is a spam. The Gmail moves that to the spam. And again, this is not a perfect example. That's why uh, some of the time our most of our emails are moved to spam, which are not even spam. But the reason is those emails are written in a very bad manner. So that's why Gmail think like this is a spam. This is not an official email. Then there's a driverless car example, as we were discussing Tesla and Google. There is recommendation contents, like if you YouTube you start listening to pop music, and in the later days you will see recommendation of pop music in your mobile and in your YouTube web as well. Then there are trading signals. If you guys are familiar with forex, there are certain boards available in forex which do trading signals, but which let us know like now we need to invest, or why now we need to withdraw our money. That is also based on trained data. Then there are AI assistants, just like Siri is available in our MacBooks or in our iPhones. Then Google Assistant is available in our Android mobiles. Those are called artificial intelligence assistants, and they are trained on test data, so they can actually listen to our voice commands and they can reply to them as well. There are many more in the queue of the application of machine learning, but this is just a start. So we will do it time by time, but we will do it continuously. But for reference, I just wrote a simple script to let you guys know like we'll be working with Python. But for now, don't confuse with the statement if you are not familiar. We will learn Python in line by line as well. But for now, we have introduced a NumPy library, which is a test data library where we can generate random data. We have imported the matplotlib library, which is actually used to plot data on the screen, like making graph. On the NumPy, we have generated some type of string, and also on the NumPy, we have generated another type of string array. So these are two arrays, and for these of two arrays, let me show what data these are actually generating. So these arrays are actually generating some type of data, and that data is passed to the graph later. So that graph is shown on the screen to show the data. Either we can see the data on the graph as well. So what we can see here, this is our test data plotted, where x is between 1 to 5 and y is between 0 to 500. The reason is we have generated x from up to 100 in first terms each, and we have generated up to 1040 terms each, and then we have divided by x. That is why this is going so smaller and this is going so higher. So this is our test data. What this test data tells us, this test data tells us the our machine will learn, like if there is a 1, it should be mapped to like 100. If there is a 2, it should be mapped to like 80. If there is a 3, it should be mapped to like 40. So our machine learns time to time. Based on these learning, in future if we will ask our machine like what is x of 2, the machine will tell x of 2 is 80, or machine will tell x of 2 is 100. So this is called test data. But don't confuse with this. This is just a start of the track. By tomorrow's lecture we will start learning machine learning in depth, but for now you guys can have a look at these presentation, listen to it, start exploring about machine learning, and post your comments in the comment section if you need any type of help. Thank you guys, have a great day.